Okay, so this looks like quite a tricky problem. We're approaching 0 from the right, and what we have here is if we tried plugging it in, we would get 1 over 0, which is interpreted as infinity, minus another 1 over 0, which is also interpreted as infinity. So this is another indeterminate form of the type infinity minus infinity. Okay, so the first thing that we should try to do, since we have two different fractions here, is to try to combine them into one fraction. And so to do that, well, we need the common denominator. So this guy, the first fraction, is going to need a square root of x squared plus x, top and bottom. And this fraction, the second one's going to need a square root of x. Okay, so if I combine those two, well, I'm going to have one fraction with the denominator is going to be square root. Now, since they're both under the square root, I can just bring the x inside. So this would be, if I multiply the x inside, I would have x cubed plus x squared. X cubed plus x squared. Okay. And then on top, I'm going to have x square root of x squared plus x minus square root of x. Okay, so this looks like quite a conundrum. So why don't we try doing our usual trick that we use? Why don't we multiply by the conjugate? So if we multiply top and bottom by the conjugate, we would multiply by x squared, square root of x squared plus x, plus square root of x. Top and bottom. And that would give me, on the numerator, I'm going to have x squared plus x minus x. And on the denominator, I'm just going to have square root of x cubed plus x squared times square root of x squared plus x plus square root of x. Okay, now the obvious thing is that these x's cancel. Now, not so obviously though, is here, notice that if I factor out an x squared, I would get this, and actually I can take out this x squared outside of the square root as an x. And if I do that, let's see what happens. I'm going to have x squared over x square root of x plus 1 times the square root of x squared plus x plus square root of x. And so one of these is going to cancel with this one. And if I now plug in 0, I would get, here I have 1, 0 plus 0 plus 0. So on the numerator I would have 0. On the denominator I would also have 0. So this is still an indeterminate form, which means that I haven't quite solved the problem yet. Okay, so let's continue. So let's rewrite it. We have the limit as x approaches 0 from the right of x over square root of x plus 1 times square root of x squared plus x plus square root of x. Okay, so this is what we have left over, and we just saw that we still get an indeterminate form, so we have a little bit more work to do. Now in calculus, well, sometimes we factor out funny things, and what we're going to do here is we're going to factor out a square root of x. And so if we do that, what's going to happen is we're going to get so we're going to leave square root of x plus 1, and then if I factor out a square root of x, I'm going to have inside of here, I'm going to have a x plus 1 left over inside of the square root, and then plus 1. So we basically factored out a square root of x from this one and this one. And notice that if you FOIL out this square root of x, if you distribute it, you would get back to this point. Okay, and then notice that these two, this square root of x, if you think of it as a fractional exponent, this cancels with 1/2 of this one, and so what we're really left with is a x to the 1/2 on the numerator. And on the denominator, I'm left with square root of x plus 1 times square root of x plus 1 plus 1. And now if I plug in 0, notice that I get 0 on the numerator, but now this time in the denominator I'm going to get 0 plus 1 is 1, and then on the inside I get 2. So 0 divided by 2, now that's equal to 0. And that's my answer. Now this happens sometimes in calculus. It should be noted that back here, this problem could have been made easier if in the very beginning we would have factored out a square root of x from this one. We would have had a much easier time with the simplifications, but that's assuming that you know how to get to the answer before you look at the problem, and of course you don't always do. But as you practice more, you'll get better at recognizing the different types of problems and what technique to use in each one. And in this case, we sort of did a little bit more work than was necessary, but eventually we got to the correct answer, which is 0.